So hello guys, I am back with another new problem. So in this video, I'm going to solve the question number three of today's contest. So it was a quite difficult question, but and I have seen that around lot of means there is a lot very low acceptance rate. So that's why I think it is a good time to make video on that topic. So let's understand what this question says and how we can solve this. What is the approach behind this question? So question is that longest almost palindromic substring. They have given you a string in which you have to find the longest palindrome. In which suppose here it is here they have given a string. Uh, if we remove character C from this string, then it can be it can means it can be it can be called a palindrome of length 3. Let's take another example. If we remove Z, if we remove Z here, see here, this is a palindromic string. Even if we include Z, mm, even if we include Z in substring, and and removing Z will also satisfy the condition. So our length will be going to be of 5. So what we can do is that the means the best approach is to do this problem is that let's see how I've done here. So I have created a two function. One is solve function and another is equal function. Hmm. And what I have done here is I have iterated over each and every character of the given strings. And I have performed some operation on that so that I can find the with maximum length with exactly means with means I can how can I can say that with exactly removing only one character from it. Means the way to do is that I have iterated over each and every character of given string. Now what I have done here is that I have just taken the I just taken the three indexes, which is the current index and the next index and the previous index. So what that does that mean? I will explain you. Be with me. So after that, I have called the function equal function. hmm, with two parameters L and R, and other parameter is L2 and R. So here I've done some operation. So let me explain you what I'm doing. Suppose suppose we are on index one. Hmm. Suppose we are on index one means on B, and what we can do, we can either check that either either this AV is AV is the half part of palindrome to this CA or not. If it is, then it will return the out. Means if it is, then it will return the length of the given string. What I'm seeing here is that here, suppose I am on B at index one. So I have initialized L with I means the current index, and the second index is R, which is I plus one means I am on C. And third index is I minus one, which is 0. See here, what I am doing is wait. Let me explain you with the pictures. So guys, just see here. We know that we know that uh, we know that this is also called a palindrome, and this is also called a palindrome. So difference between these two examples is that there is a one middle element which don't have a means which don't have a copy means don't have a correct same character. Here see here there is means this palindrome is of odd length and this palindrome is of even length. So we can say that means we have to consider about these two cases during solving this problem. And see here we have given we have taken this example. What I'm doing, I am on currently this index. Suppose this index is I. Hmm. And what I'm trying to do is I have taken L is equal to I, Let me write here first, then after that I will start a video so that the video will. So you can see here in the solve function what I'm doing here is I've just defined these three variable L, R and L2, and I'm calling the function. I'm calling the equal function with L and R. With initial count value equal to 0, and another same function equal with variable L2 and R2 with count equal to 0. So let's see what we are doing in equal function. So suppose which means I've just written those L and R here, which we are going to use in equal function. I have called means I have called here equal function with L and R, and second is L2 and R with the same. So see here, what this equal function is doing here is that that suppose we have to take this L and R now. So initially the L is I, and the R is I plus one. So so this is R plus one. This is R plus one. So what I am doing in equal function is I am just checking whether that this this the element present at L is equal to R or not. So here it is not. It is not equal. So what I am doing here is that see here, until the current element at here, I'm just handling the edge cases now. See, I'm just checking that the element present at current L is equal to character at R or not. If it is equal, then I'm just reducing the left index and right index. Not reducing the left index and increasing the right index. So if it is not equal, then it's come out from this while loop. And what we have to do, we have to check that whether this count. So what this count is stored is that the count is stored at means number of time we can means number of time we can means number of time we can exactly remove that one character. So count is stored the number of character which we can remove. So initially it was zero means initially it was zero means that we until we have until now we haven't removed any character. So initially it was zero. So I have just checked here that whether count equal to zero or not. So for this case is so initially initially this character is not equal. So we come out of this while loop, and we have checked that whether count is equal to 0 0 or not. So it is means count is equal to 0. So here again I am handling the edge cases. So what I am doing here is that again just skip for now, just skip these cases for now. I'm handling here this okay, this edge cases now. What I am doing here is again I'm calling the equal function, which is now the left is equal to L and R is R plus 1. So previously this is L and this is R. Now again I am calling the equal function with same left, and R is increased by 1. What I will do now is that I will keep R here, on another X. So now what we have to do, we have to perform the equal function again. We will check whether this L is equal to R or not. So it is not equal. So what we will do, we will just we will just we will just come out from this while loop. We will come out from while loop and check whether this count is equal to 0 or not. So previously in previous call, count is set to 1 now. So this time it will not satisfy this condition. So we will come in else block, and it will return R minus L minus 1. So what is R minus L minus 1? So this will be the length R minus L. R minus L is suppose 1 2 3. So let's think of I plus 1, I plus 2. So I plus 2 minus I is equal to 2, minus 1 is 1. So it return length 1. Means it return length 1 means uh, it return length 1. So it return length 1. Now we will check the other condition, which is which is which is we have to do L minus 1, which we have to now check for L minus 1 and R. So for previous cases, we have just moved R from R to R plus 1, and now we have to move that L2. We have to move L to L minus 1. So our S will be here only, and sorry, R will be R have to be here only. Now we have to move L. So now this L going to be here. So we have to check again whether this, we are now in while loop. We have to check whether this character at L is equal to character at R or not. So here they are. Now what we have to do is we have to just reduce the left by 1 and R by 1. We have to do unary increment. Now our L will be, now our L will be on this and R will be on this. So we have to check again whether L is equal to R or not. So it is. So we have to move L again. So our L will be here after one iteration, and I will be here. So we have to check whether they are equal or not. So it is not, and count value is again, count value is again count value count value will be again not, means count will be again here, count initially our count value is 1, so it will directly return the value of R minus L minus 1. So R minus L minus 1 will be this. So count of this is 5. So our equal function will return max of these two value. So max of these two value is 5. So initially we have called with L and R, and the value of L and R here is 5. So just be with me. So what I will store here is 5, and we have to again calculate for L2 and R. See here, we have to again calculate for L2 and R because we are calling equal function from solve function. So now we have to do for L2 and R2. So let's remove these things. So previously we are taking, so initially we have taken is this index element na. So now L2 will be on this and R L2, and R will be on this character. Now we will check again. We have here called in equal function now, so we will perform all this operation again until this doesn't see here. So character at L2 is equal to character at R, so we have to move L2 at we have to reduce L2 value and increase this R value, and we have to check again whether this L character at L2 is equal to character at R or not. So here it is. We have to move L2 again. Now our L2 will be on character B, and our R will be on character D. Character D. We have to check whether the character B is equal to character D or not. So it is not. Means character B is not equal to character D. So what we will do here is that we will check whether count value is 0 or not. So initially we have called equal function with count equal to 0, so it satisfied the condition, means we can means we can perform one operation, means we can remove one character currently. So what I am doing here is that I am removing the, for first case I am removing the current art index, means art index character, and in this case I am removing the current alt index character. So see here, means there will be two cases now. So initially I am what I am doing here is that I am taking the first case, which is removing the art character, means increasing the value of R to R plus 1, increasing the value of R to R plus 1. Now R will be on B. Now what I'm doing again here is that I'll just check whether the character at L2 is equal to character at R or not. Yes, it is. So it will keep checking until we will be out of this. Means it will satisfy all the cases now. So we will be here when I value will be, sorry, L value will be -1 and R value will be, L will be length. Suppose n is the length of the given string. Then what we have to return? We have to return, see here, it satisfied these edge cases. That's why I've already, previously I've informed you. In it. So what it will do here is that we will check. It satisfied this condition also. We will come out from the while loop. So we will check whether count is equal to 0 or not. No, it is not, because we have called this equal function with count initially as a 1. So we will check. We will return here r minus l minus 1. So r minus l minus 1 will be the number of character between this. So it is 3, 3 to 5, 6, 7, 8, 9, 10, 11, 12. So it will return 12 from first equal function. Now second equal function is second equal function. What second equal function is do here is that it will reduce the, it will remove the character from L index, and R index will be the same. So what we have done here earlier is that here what we have done, we have previously what we have done here is that we have just removed our art index, to R plus 1 and kept L as same. So what we will now do is we will reduce the value of R, means we will try to increase the value, means we have just reduced the value of L by 1. Now what we will do, we will keep check this while condition. So we will see here that whether the character present at L2 is equal to R or not. So it is not. So what it will return, it will return now count value is 1, because we have called here equal function with 1. So what it will do, it will just simply return the R minus L minus 1 value. So what we will get here is that 2 plus 1, 3, 4, 5, 6. It will return 6. So max value of 12 and 6 will be going to be 12. So it will return 12 function. It will return 12 to solve function. So we will get 12 from this equal function. So now what we here we get is that we get 5 and 12. So at the end, what it will do is it will return the max of 5 and 12, which is 12, which is 12. So from which is 12. So from this we can from this we can solve this problem this way. So with this we can solve this from this way. Sorry for my bad English, because I don't know how to speak. So that's why I'm improving here. So this way, I think I'm quite clear that I'm able to explain you this problem more means in good. I don't know how I've done, but I think this is enough for this. Is that's it from my side. So we will be taking tomorrow with a very new problem. So for that, goodbye and have a good time with your family.